Good day, everyone. This is Chris back again with the Ancient Scholar. So today what I'll be talking about is more periodic trends. The last video, video number 3, we had talked about the trend known as electronegativity, and what I'd like to talk about now is something known as the atomic radius. So we'll go ahead and talk about the atomic radius. Okay, so what is, first of all, let's just refresh ourselves on the concept of a radius. So let me move up here. So if you can imagine that I have an atom, and I've got the nucleus in the center, protons and neutrons, and then I have the shell or shells. Maybe I have more than one shell. Maybe I have 2 shells or 3 shells of electrons around the nucleus. The radius is basically, when we talk about radial distance, we start at the nucleus, and we start at the nucleus, we go from the nucleus all the way out to that outer shell, and that distance is known as r, or the radius. That is the radial distance. Whatever that distance is what we call the atomic radius. Now, the interesting thing about an atom is that atoms are kind of fuzzy. And that is to say that the radius is not well defined. Atoms are not literally a sphere like we'd like to think, and that the boundary of where the atom is and where it isn't, it's kind of fuzzy, and we're not really sure. So what we do is the radius is basically it's kind of a fuzzy boundary, and it's basically what we call the most probable radius, or where most of the time, so if I have the nucleus here and I have a couple of shells, most of the time we will find the electrons within a certain space, within a certain volume around the nucleus. And sometimes the electron could be out here, out here, out here, maybe way out here, even out here. But most of the time it's going to be within a certain distance. And whatever that distance is what we call the atomic radius. So that's not to say that the electron or electrons within that atom can't be out further than the radius. It just says that most of the time we'll find them in the radius. Okay, well, fair enough. So let's go back here. So what I've done is I've taken the periodic table of elements, and this is actually a picture from the Oklahoma State University Intro to Chemistry site, just a reference where I got this picture from. And basically what I have is I have a really neat kind of a redrawing of the periodic table of elements. You can see that I have kind of this sphere here, and this is actually a visual representation of the atomic radius trends. And you see that little a with kind of a circle or dot on top of it, that's known as an Angstrom. An Angstrom is a very, very tiny fraction of a meter. If you remember from learning how to measure things, obviously are measured in meters, and then you can break the meters down into centimeters, millimeters, micrometers, and so on and so forth. An angstrom is much smaller than even a micrometer. It's tiny, insignificant. Okay, so let's just talk about the general trend of atomic radius. Generally, the atomic radius will decrease. Okay, it will decrease as we move to the right on our periodic table. So as we move right down a period, our atomic radius will become smaller. So here I have lithium at 1.52 angstrom, and as I move to the right, I go through beryllium at 1.1, boron 0.88, carbon 0.77, nitrogen 0.7 angstrom, 0.66 angstrom, 0.64 for fluorine, and 0.7 for neon. You can see that this isn't exact. Okay, This is an exact trend because here I have neon has just a tiny little larger radius than fluorine. But as a general rule of thumb, my atomic radius of the atom itself will decrease as I move down or as I move right along a period. Likewise, my atomic radius is generally going to increase as I move left up a period or a row. Okay, fair enough. My atomic radius is also going to decrease as I move up a group. So here I have cesium, very large, 2.62 angstrom. Moving up, potassium here, I have sodium at 1.86, lithium at 1.52, hydrogen way up there, tiny, at 0.37. So you can see a general trend. So again, atomic radius will decrease as I move to the right, and it will decrease as I move up. Okay. Likewise, the atomic radius is going to increase as I move to the left and increase as I move down my groups. All right, fair enough. Well, why do we see these general trends happening? Well, why do we see the radius decrease? Let's just, I'm going to draw a little box around this period here. Why do we see the radius generally decreasing? Well, let's see what's going on with the atom. So this is period 2, so that means that all of these elements are within the same shell, right? They're all within the same shell. So all of these elements have 2 shells of electrons, an inner shell and an outer shell. So that doesn't change, but what does change is the nucleus. So what I'll do is in blue here, I'll draw the nucleus right here in the middle. See a little dot there. And as I move to the right, I have more protons. I increase my protons in the nucleus, and more protons means that there is more positive charge to attract those negatively charged electrons. And as I have more and more and more and more negative charge or positive charge in the nucleus, it's going to pull on those electrons, and it is going to pull the electrons in toward the nucleus more, and in essence it's going to kind of shrink the radius of the atom. It's perhaps a bit more complicated than that, but that's a good qualitative way of looking at it, at least at this point. Now likewise, as I go down, we'll go to green here. As I go down, we'll go here. As I go down, let's make that a little bigger. We see that the radius becomes larger. Well, why would we see that? Well, that actually should be fairly simple, because as I go down, what I see here is up here at n equals 1, I only have 1 shell for electrons to go into. 2, I'm going to have 2 shells. Okay, so I would expect the radius to become larger. Down here, I'm going to have 3 shells, even larger. Down here, I'm going to have 4 shells. 1, 2, 3, 4, even larger yet. Okay, so the number of shells is increasing as I move down the periodic table of elements, or as I move down my periods, as I increase my periods or move down the group. Likewise, as I move up, my period number is going to decrease. So down here, I'm way down here. So I start 1, 2, 3, 4, 5. I'm way down here at 6 shells, and now I have 5 shells. 4, 3, 2, 1. So that's kind of the basic qualitative understanding of the trending in atomic radius. As always, guys, thanks for hanging in there.